Designing a distributed cache is a crucial step in optimizing the performance of distributed systems. By implementing a distributed cache, you can reduce data access latency, alleviate database load, and enhance the system's scalability and response speed. Below, I will outline how to design a distributed cache system and briefly describe several common types of caching. In a distributed environment, data needs to be distributed across multiple nodes. To ensure that cache data is evenly distributed, consistent hashing is typically used to determine which cache node will store the data. This way, when the number of nodes changes, data redistribution can be minimized, maintaining the stability of the cache. Cache consistency is an important consideration when designing a distributed cache. In practice, cache consistency issues typically arise from two aspects. Write after read inconsistency. When the written data has not yet been updated in the cache, the read operation returns old data. Cache expiration mechanism. A time-to-live teach strategy can be used to automatically invalidate cache data after a certain period. Another option is to use active invalidation, such as notifying all nodes through a message queue. When using a distributed cache system, it is essential to ensure high availability and partition tolerance. If a cache node fails, the system should be able to automatically redirect requests to other cache nodes. Implementing replication mechanisms or deploying multiple data centers can enhance the system's fault tolerance. A distributed cache can incorporate a persistence mechanism to ensure that data is not lost if a cache node crashes. Three major types of caches. In the write-through strategy, write operations update both the cache and the underlying storage, such as a database, simultaneously. Advantages. Ensures strong consistency between the cache and the database, as each write is immediately updated in the database. Disadvantages. Performance can be poor because each write accesses the underlying storage, increasing write latency. In the write-back strategy, data is first written to the cache and the operation to write to the database is delayed. The cache system asynchronously writes the data in the cache back to the database in the background. Advantages: better performance, as write operations do not require accessing the database each time, resulting in faster writes. Batch writes can improve the efficiency of write operations to the database and reduce the frequency of small writes. Disadvantages: there is a risk of data loss since data may not be immediately written to the database. Data consistency can be poorer, as the system may read old data for a short period. Write-around is a variant of the write-through strategy. In the write-around strategy, write operations bypass the cache and write directly to the database, while read operations fetch data from the cache. Advantages: avoids the overhead of frequently writing to the cache, making it suitable for systems with fewer write operations. Works well for larger data sets, as it does not invalidate the cache due to frequent writes. Disadvantages: if the written data is frequently read afterward, the initial read request may miss the cache, leading to latency. High consistency requirements. For scenarios requiring strict data consistency, such as financial transactions or order processing systems, write-through is commonly used. This approach ensures that the system always provides the most up-to-date data when read. High performance requirements. For systems that require high write performance and can tolerate short periods of data inconsistency, such as logging systems or analytics systems, write-back is more suitable. By delaying writes, it reduces frequent small write operations, thus enhancing write throughput. Read-heavy scenarios. In systems with a high volume of read operations and fewer writes, write-around is a good choice. By avoiding frequent cache updates, it can improve read efficiency and reduce the maintenance burden on the cache. In distributed caching, it is important to address hotkey issues, where a single key is accessed frequently, leading to concentrated load on certain nodes and potentially causing performance bottlenecks. Common methods include request diversion, cache replicas of hot data on multiple nodes to distribute access requests. Local caching, store hot data in a local cache on the server to reduce load on the distributed cache system. Asynchronous processing, use asynchronous batch processing to reduce the frequency of hot data requests.
Thanks for watching. For more information, please visit lautcy.com.